Alrighty, this video is going to be on polynomial inequalities and rational inequalities thanks to our DECA kids. Yay! The first thing that I'm going to do for number one is look at this polynomial function, and we see that it is a quadratic function. So for number one, I can probably sketch this by finding my roots. So what I'm going to do is find my roots of x squared minus 5x minus 6 by factoring. I get 6, and then I get negative 1. I'm going to plot them in on a number line, and you'll see this number line in your packet. Because you have a greater than symbol, you are going to have an open circle at negative 1, and you're going to have an open circle at 6. And because it is a quadratic function that is easy to graph, you can go ahead and just sketch this like that. And once we do that, we are trying to look for when our function is greater than 0. In other words, when f of x is greater than 0 means that when is it above the x-axis? It's above the x-axis here, and it's above the x-axis here. Because of that, I could look at my interval and say that it's from negative infinity to negative 1, union 6 to infinity. Now, that was one way we could have done this, just because we know how the graph of a quadratic function looks like, and we know how to sketch it. Another way is using our roots of negative 1 and 6 by using a sign chart and testing values, which you will see on DeltaMath. In other words, we have negative 1 and 6 that are my zeros. I am going to pick a test point from this region, and this region, and we're going to look at the sign of that value, whether it's positive or negative. And that's going to help us see if it's greater than 0, then it's positive. If it's less than 0, then it's negative. For example, I might plug in negative 2, and let's see what happens at negative 2. I'm going to use the factored form. Negative 2 minus 6 is negative 8, which is negative. Negative 2 plus 1 is negative 1, which is negative. A negative times a negative is a positive, which means that to the left of negative 1, my sign is positive, which makes sense because from here to the left of negative 1, it's positive. I could do the same thing for 0, and I would always plug in 0 if you have a chance, because that's the easiest one to plug in, because here, that's just 0, so you're just left with negative 6, which is negative. Finally, I'm going to plug something to the right of 6, so let's just say 8. If I were to plug in 8, I'm going to get 8 minus 6, or positive 2, which is positive. And then 8 plus 1 is 9, which is another positive. Positive and a positive makes a positive, so I know that is also positive. So anything to the right of 6 is positive, which makes sense right here. So looking at your sign charts, this tells me that I am positive from negative infinity to negative 1, and I'm also positive from 6 to infinity, which is right here. Now, if you could graph it easily, then I would tell you to sketch the graph and then look, does it need to be above the x-axis or below the x-axis, depending on what your sign is. In this case, since it is greater than, I'm looking above. We're going to do number 2, similar fashion, where I have this polynomial, and it's a cubic function. We know what a cubic function looks like because it either looks like this or it either looks like this, depending on the leading coefficient. Because you have a leading coefficient of 1, your end behavior should look something like this. Now, looking at x cubed minus 9x squared plus 24x minus 16, if I wanted to find my zeros, one might think, hey, let's factor by grouping and see what happens. So if I factor by grouping, you're going to notice that you have x squared, x minus 9, 8, and 3x minus 2, which takes us to a little dead end on a factoring, which means we're going to play our favorite game called the guessing game, aka the rational root theorem game. So you have factors of 16. All of that's going to be plus or minus. And now you just really need to guess which one of this is going to be the correct factor. So let's go ahead and guess one. Let's see what happens here. Oops, that should not be. Okay. Oh, lucky guess for me, 1 works, so I know 1 is a factor, or 1 is a root. My quotient is x squared minus 8x plus 16, which is my leftover, or x minus 4, x minus 4. So my roots are 1 and 4 with a multiplicity of 2. I'm going to sketch my graph looking at 1 and looking at 4. My end behavior should look something like this right here. I have a bounce at 4. And at 1 and at 4, it is going to be a closed circle because I have a greater than or equal to symbol. Since I have a greater than or equal to symbol, I'm looking when my graph is above the x-axis. This case, right here, right here, right here, right here. Just like unit 1, where I took half of a point off if you gave me 2 intervals, I'm also going to take half of a point off if you give me one of 4 and then 4 to infinity. Just use one big interval because that's what it is. It's one big interval from 1 to infinity. Now, if you did not know how to graph this, you could use a sign chart to test out your points, which I'm not going to do, but you guys can do that on your own. For number 3, this is where we get into the point of where I don't know how to graph this because it's a rational function and I don't know how this looks like. Even though it's an inequality, we're still going to use the sign chart that we did in example 1 right here. And we're just going to mimic this because I don't know the graph of this rational function and how it looks like. Now, to solve for inequality that is a rational function, here's what you're going to do. You're going to set the numerator equal to 0. Oh, no, that's horrible spelling, but, you know. Numerator equal to 0. And it's either going to be closed or open depending on sign. Since my sign here is just less than and strictly less than, you know that it is going to be open. You're also going to set the denominator equal to 0. And this will always be open. And the reason why it's always opened is because it's a vertical asymptote. So we're essentially trying to find out where the vertical asymptotes are. And since we can't touch it, it's going to be open. Looking at number 3 right here, I have x over x squared minus 5x plus 6. I know that I have a 0 right here. And then factoring out x squared minus 5x plus 6, get x minus 2, x minus 3. So I have 3 points, which is going to give me 4 regions. I'm going to have a region right here, a region right here, a region right here, and then a region right here. So let's say that I have a negative 1 here. Let's say I have 1 here. Let's say I have 2.5, and then let's say I have 4. So at -1, I'm going to see that I have a negative on top. And then at -1 right here, -1 minus 2 is a negative. And then -1 minus 3 is also a negative. I have a negative. Why do I keep on doing that? I have a negative and a negative on the bottom, which gives me a positive at the end. But then I still have a negative on top, so a negative divided by a positive is going to give me a negative. So my sign to the left of 0 is going to be negative. Now, if I were to plug in 1 right here, I'm going to get a positive on top. And then 1 minus 2 is going to be negative. 1 minus 3 is also going to be negative. A negative and a negative makes a positive at the bottom. And then a positive over a positive gives us a positive. We're going to do the same thing with 2.5. So we know on top it's going to be positive. 2.5 minus 2 is going to be a positive 0.5. And then 2.5 minus 3 is going to be negative. A positive times a negative is a negative at the bottom. And then we have a positive over a negative, which means that it's negative. I think I said this earlier. Likewise, I don't care about the value of the y value. The only thing I care about is the sign at each region. At 4, I have a positive value on top. And then on the bottom, I have 4 minus 2, which is positive. 4 minus 3, which is positive. A positive over a positive times a positive is a positive. Now, at 0, 2, and 3, we know that 2 and 3 are both open. And then at 0, it is open because my sign is just a less than symbol. Since I want a less than answer, then I'm looking at when my graph or when my sign is negative. In this case, it's going to be from here and from here. So my answer would be from negative infinity to 0, union 2 to 3. That's what you would do for that one. Likewise, for number 4, we're doing the same thing, except this time we have a less than or equal to symbol. Since we have a less than or equal to symbol, I know that my numerator will have a closed circle. So I'm going to factor out x squared plus 10x plus 21. That's going to be x plus 3, x plus 7. I have 6 on top, -3, -7 at the bottom. Going to go ahead and pick out my points by ordering my test regions, test points. So I have -7, -3, 6. At -7 and -3, there are both open, and then at 6 it is closed. I'm going to pick -8 here, -4 here, 0, and maybe 8 here. Okay, so I have x minus 6, x plus 3, x plus 7. If I were to plug in -8, this is going to be negative on top. At the bottom, I have -8 plus 3, which is negative, and then -8 plus 7, which is also negative. Negative and a negative makes a positive. But then I have a negative right here and then a positive right here. So this right here is negative. At -4 minus 6 is negative. -4 plus 3 right here is negative. And then -4 plus 7 right here is positive. So that means a negative and a positive makes another negative. A negative and a negative makes a positive, so at -4, we have a positive value. 0 should be easy for you to look at because you just have -6/21, which is negative. And then finally at 8 minus 6 is positive. 8 plus 3 is positive. 8 plus 7 is positive, so you know that this is a positive value. I am looking at a less than or equal to sign right here, which means that I am trying to look for a negative value. So this means that my answer should be from -infinity to -7, where -7 is in parentheses. Then -3 and 6, where -3 is in parentheses, and then 6 is in brackets. That being said, the whole packet is in the student notes folder. You can look at that and then do the rest of the problems. Your test is going to be fair game, so what we covered today and what we covered on the quiz and everything else in between is fair game for Monday's test. So for my DECA kids, make sure that we're studying after we come back, but for now, focus on DECA, I guess. Have fun and study.